browser. In browser.
Welcome to clickmyproject.com.
Our product title is Adaptive Positioning Control of an Ultrasonic Linear Motor System. Let us see about the abstract of our product. In this implementation designed for use as the objective stage of a scanning electron microscope. To improve the tracking accuracy of the parallel platform, the positioning control algorithms for the drive joints needed to be studied. The dead zone phenomenon caused by static friction reduces the trajectory tracking accuracy, and also it significantly linear control algorithms such as PID, proportional integration differentiation, are unable to compensate effectively for the dead zone non-linearity. To address this problem, two types of feed-forward compensation control algorithms have been investigated. One is constant feed-forward with the integral separation PID. The other is adaptive feedback and feed-forward based on the model reference adaptive control. Simulation and also conducted using these two control algorithms. The feed-forward with integral separation PID algorithm can compensate for the time invariant system after identifying the dead zone depth, while the adaptive feedback and feed-forward algorithm is more suitable for the time-varying system. Thus, results show good agreement with the simulations for dead zone nonlinearity caused by the static friction. The adaptive feedback and feed-forward algorithm can effectively improve the trajectory tracking accuracy. And one important thing in this process only we did in the control algorithm, and also that is the client requirement. So is the flow and also control diagram only we did in this process. So corresponding output only here we provide, and also the control blocks is given in the next. We see about the flow diagram of our product. This is our flow diagram. One important thing, this flow control only we did in the MATLAB simulating environment. So in this flow diagram, the signal generator is generate the signal and then fed into the reference model 1 through a gain. The gain having some values, and also then that value is product into feedback of the output, and then is added with also one integrated from the feedback from the output, then is fed into the actual system, and also the product of that value is fed into the reference model 2. Finally, those three values is added and also that fed into the output side. Then that value is product into gamma and also integrated value, then fed into the feedback position. The modeling and control of a quadrator type QAV. The reason for choosing the quadrator is in addition to its advantages that will be addressed later. The research field is still facing some challenges in the control field because the quadrator is a highly nonlinear multi-vibrable system, and since it has 6 degrees of freedom but only 4 actuators, it is an under-actuated system. Under-actuated system are those having a less number of control inputs compared to the system's degrees of freedom. They are very degrees of freedom difficult to control due to the non-linearity coupling between the actuators and the degrees of common flight control algorithms found in the literature or linear flight controllers. These controllers can only perform when the quadrature is flying around over. They suffer from a huge performance degradation whenever the quadrature leaves the nominal conditions or performs aggressive. The contribution of this work are deriving an accurate and detailed mathematical model of the quadrature UAV, and also that applying those on the derived mathematical model in computer-based simulation using MATLAB simulation. Next, we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First, open the MATLAB window and create a new model file. After creating that new model file, we opening the simulating library browser. From the simulating library browser, we get the elements and then arranging that elements as per given flow diagram. After arranging that elements from flow diagram, then we click the run icon. And also in the MATLAB in simulating library browser, we using two major blocks. One is SimPower System tool and another one commonly in the commonly used bug, they have the scope, and that scope is connected the output area, and also then after clicking the run symbol, then the corresponding output is shown in the corresponding scopes. So this is the model file. After that, opening, click the run icon, then the output will be shown. In this proposed implementation, we did in symboling, and also that output is fed into the M file. So in the M file, we only plot the graphs for versus displacement versus time, and also displacement unit is millimeter, time in seconds. So next one is the error versus time plot graph, and this is the input variable, and this is the after plotting that, and this is the output, each reference model output. So this is the actual system model output, this is the reference model 2 output, and also final output is shown here. So using of this implementation, we only did in the control algorithm, and also the reference and actual system, and also RLS algorithm will be implemented, and also similar to with and without compensation technique is implemented, and